times a vector c1 up to cn minus a vector c1 up to cn. So I won't even use ket notation, right? So what is this matrix times this vector? It just adds up c1 through cn in every row. Every row is the same. Then it averages it, divided by n. So what we end up with is equals sum over I of minus c sub I plus 2 times 1 over n sum over j of c sub j. Ket I. So this is the average value of all the coefficients, and then it's times 2 and minus what you started with. Yeah, so what this reflection is doing is it's let's just draw a picture maybe. If these are the coefficients initially, let's see, what's a good way of seeing it? Yeah, so let's just pretend that these are the coefficients initially. So this is 1, 2, 3, 4, 5, etc. This is C1, C2, C3, C4, C5. The heights, the vertical heights. So then what this says is you compute the average. So the average looks like it's roughly, maybe that's too high, I don't know. Right, so that's supposed to be the average of these 5 numbers. Now we take minus c sub I plus twice the average. What does that do? Okay. Oh, okay, it's not bad, it's not bad. Look, here, look. So this distance from here to here, this distance is C1 minus, I'll call it C bar for the average. So C1 minus 2 C bar is here. So this height is C1 minus 2 C bar. If I call this C bar. So if I had C1 minus 2 C bar, it would just reflect about this average. So C2 would become C2 minus, would become up here. C3 would be there, C4 would be there, C5 would be there. So it's just a reflection of the coefficients about the average. And then there's an extra minus sign because it's annoying. But I mean, the extra minus sign is a global phase, it doesn't actually matter. So essentially what this, we call it a diffusion operator. Reflection, whatever, diffusion. Essentially what it's doing is it's reflecting the coefficients about the average value of the coefficient. I don't know if that's useful, but it's true. Still, the question is, how can we generate this reflection, like using Hadamard gates and gates that we know, gates that we understand? How do we generate this unitary? So that's the interesting question. All right, so let's do something more general. Yeah, so here.